Okay, so when we first, at the very beginning, started talking about acids and bases, strong acids and bases, we saw that acids were things that released H+, and bases were things that released OH-. It was pretty clear cut. H+ acid, OH- base. But then when we moved into weak acids and bases, we saw slightly different definitions, and I didn't actually give you that definition, but by looking at the dissociations that we did for weak acids and weak bases, you saw that not all the bases had OH- anymore. Rather, the acids were things that were always losing an H+, and H+ was falling off of them. And the bases were things that were stealing an H+ from water, and that's how hydroxide ended up being released. That's where that OH came from. So formally, there's this thing called the Bronsted Lowry definition that encapsulates that idea. That according to this definition, acids, anything can be an acid if it loses H+. And if you're looking up other videos or other notes, you might see the H+ being referred to as a proton, because that's all a hydrogen ion is a proton. But if it's an acid, if it loses H+, it is a base, according to the Bronsted Lowry definition, if it gains H+. So the Bronsted Lowry definition shows what we saw when we were looking at weak acids and bases. The base can gain H+, and that's how it releases hydroxide. But anything can be a base, even if it doesn't have the OH in it. So because of this definition, it lends itself nicely to this idea of acid-base conjugate pairs. The acid loses an H+. The H+ doesn't just disappear. It has to go somewhere. Wherever that H+ ends up going, tacking onto it, whatever gains the H+ must be a base. So wherever we have a weak acid, we also actually have a weak base, and vice versa. Those pairs are called conjugate pairs. So in a conjugate pair, you'll have something gaining H+, something losing H+, an acid and a base. The acid will always have exactly one extra H+ compared to the base. It has to have the extra H+ to lose. Therefore, the base will gain it. So for instance, if I give you a weak acid, I can ask you for its conjugate. Basically, its partner is all that means. Its conjugate weak base. So if I give you the weak acid HF, we know that our acid should have one extra H compared to its base. So its weak base must be this with one less H. So that H went away, and the charge goes down by 1. If, for instance, I give you something, I call it a weak base, H2PO4-, well, we know its acid should have one more H than it. So we can find its partner by saying, okay, put one more H on this, and it was -1, it goes up by 1 because we're adding H+. That's its conjugate weak acid. You're going to try some of those now, where you're just practicing the fact that the acid has one extra H compared to its conjugate base.